Now, in this lesson, we're going to be talking about the calculation of consistency. So hopefully you remember your accuracy factors and the calculations of your accuracy. You'll also remember how to calculate the mean observed range from your 10 ranges. What do you do?
Add them up.
Then?
Divide them by the number that there is.
Which is?
10. Well,
10. Should be 10. Yeah. Why? Because it makes it easy. Remember how to divide by 10? No. Just take that last digit, move the decimal point one place in, and it's much easier to do. This, though, is about calculating consistency. So what's the difference, do you possibly think, between accuracy and consistency?
Consistency is over time, many calculations that are coming together fairly accurately.
So accuracy is how close it is to the observed range. Consistency is how often you get that reading. So it doesn't necessarily have to be accurate to be consistent, because you can be consistently wrong. But you need to know if your instrument is inaccurate, or you're inaccurate, or there's something happening with the environment that creates an inaccuracy figure. If nothing else changes, so if you're still inaccurate, the instrument's broken, the environment's still difficult to take accurate readings, that's still consistent. So you can be consistently wrong. But it gives you a good indication of your fatigue, whether something goes wrong with the instrument. If you start to get deviating consistency readings, so if you start to realise you are inconsistent, you've got a very high consistency, which will turn into a high number, it will mean you're inconsistent. You'll start to notice that. So we need to do accuracy factors, because we can then do the adjustment and everything for those, and we need to do our consistency calculations as well. So accuracy is how close the observed range is to the actual range. Consistency is how often a similar accuracy is obtained. So it's the size of the group of readings. For anybody that's been on the ranges with their rifles, you'll understand that you can have the grouping of the shots can be nowhere near the centre of the target. If it's near the centre of the target, that's accuracy. But if it's always in the same place but nowhere near, that's consistency.
Yes.
So
consistency can still be wrong.
Yes, absolutely. Yeah, it still can't hit the target. But accuracy often improves with consistency. So it's important that you understand what this is. So why do we want to know consistency? Because you know how your training is developing, how good you are, what's perhaps happening. Does it, as I said, tell you something about, well, so I'm starting to be inconsistent. I get a really great accuracy range, but in these conditions, because we've got our accuracy charts, you've got your notebook, so you can start to look back. But over time, my consistency is getting worse. So what's happening there? Is it something that's becoming a problem? Because it can compound an accuracy problem. If you're inaccurate consistently, then you're not being a good range taker. You need to do something about it. But we only generally do something about it if it's greater than 5r squared. So if you remember your accuracy factor and adjusting ahead, we only worry about it if it's greater than 5r squared, because that's the figure. So that's 5 times the range squared. So and if you remember your r squared tables that you've got and you should have in your notebooks, these are what, when we refer to r squared, you've got your range down the left hand side, and you can start to see that 5r squared, for example, right in the middle of the column there, 5r squared for a range of 1,000 yards is a factor of 5. So it's an r squared value of 5. If you have all the way out to 3,500 yards, it's an r squared value. 5r squared is 61. So bear in mind what that 5r squared value is. If it's if your accuracy and your consistency are less than 5r squared, you never need to worry. Okay. So how do we start to calculate our consistency? And we've got two worked examples here. We're going to be focused on this, the range scale, using our mean observed range. There is also this, and if you remember from when we did familiarization with the instrument, there is the infinity scale at the top of the range scale. You have the infinity with that star and then 3 divisions above, 3 divisions below. This is how we would do it with infinity. This it's up here just as the worked example, but we're going to focus on this. The process is the same. What we're going to do is take 10 readings again, or over time, and we're going to be able to divide those by 10. But what we're also able to do is do the residual. So that is the difference of the observed range from the mean observed range. Look. So we're going to work out our 10 ranges. We're going to divide that by 10, and we're going to get, in this case, 1,839. Then we're going to go back to our 10 ranges, and we're going to say 1,839 from 1,850 gives us an 11 as a residual value. Hopefully this is the level of maths that you can manage. We've then got 1840, 1 difference. 1880, 41. 1810, 29, blah, 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 blah. All the way down, so we can then work out what our mean residual value is. So we're going to add all those up, divide by 10, and we get 19.4. And we're going to look at the r squared value of the mean observed range, which is 1839. So using our table, 1839 is the r squared value of that. Is somewhere, well, between 3 and 3, because it's only one r squared value. So 3 in this case. It's not going to change. We're taking 19.4 then, divided by the r squared of the mean observed range is 6 r squared. So 18, in round numbers, we've got 19.4 divided by 3 from that r squared table.
So you get the r squared from the table, you then
divide 19.4 by 3, the r squared of the mean observed range, and it gives us 6 r squared. So that means we have to do something about our consistency. And we'll come on to how we adjust for consistency in another lesson. But it's that one of those additional factors that you're going to start to note when you take your 10 ranges. So you can have your accuracy factor built out of the, you're going to have your mean observed range. You can start to build up your accuracy factor, and then you've got your residuals there as well. Does that all make sense?
Yes.
Yes?
Yes. It makes
Okay.
sense. Yeah.
Okay.
You can do it.
Well, you can do it. It's divided by 10, remember? So it's this residual. So if you see residual here, this is the difference from that value to the mean observed range. And then you're going to divide both of those by 10. This value, once you have these divided by 10, gives us 19.4 in this case. You're then going to find the r squared value from your table of 1839.
Which is 3 in this case.
Which is 3. So 19.4 divided by 3 equals, in whole numbers, 6r squared. We don't worry about anything, there's no need for any more, any greater accuracy at this point than whole numbers. No. So that's greater than 5, so we have to do something about it, which we'll cover in another lesson. Okay. Just to briefly cover the infinity, it's exactly the same. We'll cover how to take these readings when we do adjustments on infinity, but you're then going to end up with much smaller figures. You're going to divide, it may include a minus figure, because we've got positives and minus above or below the infinity level here on the table. So we're going to have to work out the difference to give us a total. In this case, from these, it was minus 1.6, which then divided by 10 is minus 0.16, which gives us our mean observed range. We've got the accuracy factors there for infinity, and if I just grab my notebook moment. We've got, so we've added up, we've got this residual value, we get the mean residual 0.48, and in this case what we're doing is timesing that by 10 to give us the indication of the value. So almost you don't need to do this division by 10 to then times it by 10 once you've got the mean residual from the infinities, but it gives you the value of 4.8 r squared for these figures. So in this case it's less than 5r squared, and we don't therefore need to do any adjustments. Okay, any questions on any of this?
No.
Just to be clear, because of the confused looks on your faces when we did it, we're only using r squared in this case to do the division, and that's 1r squared. So unless it states otherwise, if it just says r squared, just 1r squared. If it says 5r squared, which we need to know about whether we do this adjustment or not, then it will say, you know, we know that from what you're learning now. If it's 5r squared, that's the other value you need to know about. Unless it specifies for any reason, you know, the manual requires you to use a value other than just r squared. It's that left-hand column on the values card. So yeah, so we're going to use 1r squared. We're then going to compare it against 5r squared to work out whether we need to do the adjustments. So in the case of the left-hand, you know, the range is taken here. Would we need to do our adjustments?
No.
Yes.
Yes.
It's 6.
6.
6r squared. We need to do adjustments. For taking on infinity?
No, it's below
No.
5, so we don't.
There we go. Excellent. Okay, we can move on to the next lesson. Thank you for watching. Please remember to like and share the video and subscribe to the channel. Please support us on Patreon if you're able to, and let us know of anything you'd like to see in the future. I look forward to hearing from you.